Okay, so this is the lesson video for 2.3 over rotations. So for your bell work, I want you to write these down. It says write the component vector that maps P to P prime. So go ahead, pause the video, write these down, and then try to find the component vector that changes P to P prime. All right, so what you want to do with these component vectors is first make sure your format's correct. So component vectors always get those pointy parentheses. The first number tells you how your x values change, so how I went from -2 to 3. And then basically what you're doing is some mental math. So how would -2 turn into 3 with addition or subtraction? Well, I would add 5. So that would be the x value of that component vector. Then you do the same thing for the y values. How does 8 become -7? Well, that would be a subtraction by 15. And if you need to play around with a calculator for that, you're welcome to do that as well. How does 0 become -2? Subtraction of 2. How does 3 become 3? Well, I would add 0 to that, and that is an option in a component vector. You can have a 0 there. It just means no change for that variable. How would I go from -1 to 0? I would add 1. And how would I go from 4 to -2? I would subtract 6. So those would be the component vectors for each of those examples. So when you're done with that bell work, if you want to go ahead and select 1 through 5 for how confident you are on component vectors, that'd be awesome. Then you can get your notes out for 2.3 over rotations. So for 2.3, the objectives for today's lesson are I can rotate a figure on the coordinate plane. We are going to be rotating figures using rotation rules. So basically we have 3 rules that we're going to use that help us rotate 90 degrees counterclockwise, 180 degrees counterclockwise, and 270 degrees counterclockwise. So we're trying to rotate figures on the coordinate plane. And then also I can accurately label the pre-image and image of a transformation. Just as a reminder, the pre-image is where we're starting. The image is where we're going. The original point does not have a prime on it, but then every transformation after that you add a prime. So if you transform a point once, it becomes P prime. You can also, again, do more than that. So you can have P double prime, P triple prime, P quadruple prime, etc. for as many transformations as you're doing. All right, so we're going to do a little bit of vocab. A rotation is a transformation in which a figure is turned about a fixed point. So I imagine this like you're opening a door. Okay, when you open a door, the whole door is rotating around a fixed point, the hinge where it is connected to the wall. So that's kind of how these are working. Every rotation we do, we're going to be doing about the origin. So that's called the center of rotation. Where the rotation is based off of. So again, a rotation is a transformation in which a figure is turned about a fixed point, called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. And so that's what's going on in the example to the right. We have the center of rotation as P, and then we have this flag figure being rotated 40 degrees counterclockwise. So if you look, if you were to kind of draw a line from R to the center of rotation, and then from the center of rotation to R prime, if you measured that with a protractor, it would be 40 degrees. And then since it's going counterclockwise, we would say that was a 40 degrees counterclockwise rotation. So we will be using that throughout the day to check the rotations that we perform. Now again, we can see rotations visually. So you can see a 90-degree rotation, a 180-degree rotation, a 270-degree rotation, and they're kind of shown on this diagram, although it can be hard mathematically, particularly if you have kind of a funky ordered pair. And so what we do most of the time is we use coordinate rules for rotation. So these are the rules that we're going to be practicing. Then we kind of visually check what we know that that rotation should look like to see if we did it correctly. So here are all the rules. It says when a point AB is rotated counterclockwise about the origin, the following are true. So first off, if we have a rotation of 90 degrees, AB is going to go to the location opposite of BA. So you're literally taking the ordered pair of the pre-image and you are moving it so that it's now in the location negative BA or opposite of BA. If you have a rotation of 180 degrees, that point AB would instead be located at opposite of A, opposite of B. So again, it's based off my pre-image point, my original point. If you have a rotation of 270 degrees, AB goes to the location B opposite of A. So most of what we're doing today is practicing these rules that will do these rotations for us. So we're going to go through one at a time and we're going to practice rotating these points based off of the given degree. So it says rotate the point counterclockwise about the origin by the given angle, state the coordinates of the image. I will say also counterclockwise is kind of up to the left. So if you can imagine, it's the opposite of the way a clock works. And then you can also always refer to the arrows on that diagram because all of those transformations, rotations are counterclockwise. And we're going to focus on counterclockwise rotations in this class. We're not going to do any that are clockwise. Keeping it simple. So first things first, let's put my pre-image on my graph. A is located at 6, 0, so that's here, A. And I want to rotate it 180 degrees counterclockwise. So imagine this A point is going to swing half of a circle around the origin. Where would it be located? Okay. Now some of you are going to say negative 6, 0, which is absolutely right. And you can do that with this point, particularly because it's on one of the axes to start. But let's practice that rule because again, some of these are not going to be as easy to do without the rule. So the rule for 180 degree rotations right here, it says AB, and I'm going to write it down, goes to the location opposite of A, opposite of B. So if my original point A was located at 6, 0, I need my new ordered pair A prime to use that rule. So it says I take the opposite of A. Well, the original A value was 6, so the opposite of A would be negative 6. And then I need the opposite of B. Well, B is 0, so the opposite of 0 is 0, which is how I ended up with that point, negative 6, 0. So we use the rule. It also matches what I thought should happen based off what I know of rotations. Next, I can do point B. It's located at negative 2, 6, so let me put that on my coordinate, B. Again, if I'm going too fast, pause the video so that you can get this. And then we can use that rotation rule because, again, this is a 180 degree rotation. So all I did was I went and got the rule from above. Then I can apply that to point B. So B is negative 2, 6. Okay, I need the opposite of A and the opposite of B to get that new point. So A was originally negative 2. Well, the opposite of that is positive 2. B was originally positive 6. The opposite of that is negative 6. So B prime, or this new point, and let me write in B prime there. There we go. Is located at 2, negative 6. Right 2, down 6. B prime. And then again, does that look like it is swung halfway, half of a circle around the origin counterclockwise? Indeed, it does. Right, let's do C. C is located at 0, 3. And I'm going to do a 90 degree rotation with C. So the rule for 90 degrees counterclockwise is that AB goes to opposite of BA. AB goes to opposite of BA. So if C is originally located at 0, 3, C prime, I need the opposite of my original B value, so negative 3. And then my A value stays the same, but notice they've swapped spots. So negative 3 is going first, and then my A value is 0, is going to stay, and it's going to be second. So let's see if that worked. Negative 3, 0 is C prime. Does that look like that has gone a quarter of the way around the circle? Indeed, it does, which is what a 90-degree rotation would look like. We can then use that same rule, AB goes to opposite of BA, because again, D is a 90-degree rotation. D is originally at 4, 2. And then I can use that rule to find D prime. I need the opposite of BA, the opposite of BA. So B was 2. The opposite of B would be -2, and I'm writing that first based on the rule. A was 4, so that's going to be second based on the rule. And then we can graph that and see if that looks like it's in the right location. So D to D prime. Does it look like that went a fourth of the way counterclockwise around the origin? Yes, it does. Now, once you see how the rules work, honestly, guys, this is the same process, just with different rules. So last two I want to do are 270-degree rotations. If you want to pause the video right now and practice those, see if you can do them based off the rule, you can. Otherwise, the rule for 270 degrees is that AB goes to B, opposite of A. So E is located at -4, 0. E, -4, 0. is going to become E prime. And again, I take the B value and then the opposite of the A value. So B was 0. That's going to be written first now. Opposite of A, well, A was -4, so that's now going to be +4. So 0, 4, E prime. 270 degrees is 3/4 of the way around a circle. So that looks like it nailed it. It's in the perfect spot. And then lastly, F is at 4, -6. 4, -6. There we go, kind of close to B prime. And then again, we're using that 270-degree rotation rule. So F is at 4, -6. B opposite of A. So -6, -4. -6, -4 is going to be where F prime is located. Again, does it look like it's 3/4 of the way around that circle? It does. Okay, so again, using those rules, using the ordered pairs that we are given, and then checking with the graph. Lots of writing on that one. Now let's try transforming some figures with rotations. So we are told graph triangle JKL with vertices at 1, 3, 4, 3, and 4, 1. So let's start by putting that on my graph. 1, 3 is where J is located. 4, 3 is where K is located. 4, 1 is where L is located. I can put that on my graph. What a cute little triangle. And then I'm also going to write these down here just because, again, we are doing these with rules, and the more organized you stay, the better for this. So that's where we started. That is my pre-image. If you want to add that, you can. I feel like the more we label, the better we'll be with the vocab. Okay. Now we want to find its image after a counterclockwise rotation of 90 degrees. So again, we're gonna get that 90-degree rule. So go on your front page, find the rule for 90 degrees. AB goes to opposite of BA. I'm gonna write that down. AB goes to the opposite of BA. Slide this down a little bit. And then what we're gonna do is we are going to find the image coordinates. So J is going to become J prime. And then I need AB goes to the opposite of BA. So the opposite of B would be -3. Write that first based off the rule. And then the A value of 1. And I can graph that on my coordinates. So J prime is at -3, 1. J prime. Then I can deal with K. So AB goes to opposite of BA. So K prime. Opposite of B would be -3, because again, based on the rule. And then my A value is 4, does not change, but it's written second. I can add that to my graph. Last I have L prime. So again, opposite of BA. Opposite of B is -1. followed by my original a value of 4. So negative 1, 4. That's where L prime is located, and then we can connect that back into a nice little triangle. Now, a good way to check these is to check that angle of rotation. So if I connect L to the origin, and then the origin to L prime, I should get a 90 degrees because I did a 90-degree rotation counterclockwise, which I did. We can check that with every point. So K prime connected to the origin and K connected to the origin, I get a 90-degree angle again. Perfect. And then if I connect L prime to the origin and L to the origin, I can check that angle of rotation, should also be 90 degrees. So lots of evidence that we did this correctly using the rules and the coordinate and checking that angle of rotation. All right, one more example. Last, we're doing a quadrilateral. So quadrilateral RSTU has the vertices R at 3, 1, S at 5, 1, T at 5, negative 3, and U at 2, negative 1. So that's that original quadrilateral. You can go ahead and connect it into a four-sided figure. It's a polygon. Again, also, that's the pre-image. And I'm going to go ahead and list out those ordered pairs to keep things organized. So R is at 3, 1, S is at 5, 1, T is at 5, negative 3, U is at 2, negative 1. Now, we want to use the rule for a 270 degrees counterclockwise rotation. So I'm going to go up to my rules again. 270 degrees says that AB goes to B opposite of A. So AB goes to B opposite of A, and I can apply that to every ordered pair to find where its image would be. So R prime, I need B opposite of A. So B is 1, opposite of A would be negative 3, and that's where that new ordered pair is going to go. So 1, negative 3 is the location of R prime. Then I'm going to do S. 5, 1 is going to be at B opposite of A. So 1, negative 5. Again, the rules take a second to get used to. But once you see how they work, you're just doing that to the ordered pairs. T becomes T prime. B opposite of A. So negative 3. And then opposite of A would be negative 5. So left 3, down 5 is where T prime is located. And lastly, U is going to become U prime, B opposite of A. So negative 1, negative 2. So once I connect that back into the quadrilateral, hopefully we will see that it looks like it's been rotated 270 degrees. So a 270 degree rotation would be 3/4 of the way around the graph, and it looks like we did that. The last way that you can check this is to compare the original points with their new points, and sorry, I forgot to label RSTU prime. So I can compare some of these points. Let's do, I don't know, like T. So connect T with the origin, connect T prime with the origin, and then you would see that this is a 270 degree angle all the way around. So you can check that angle of rotation for every single original point and image point, and then you would know that you did it right. So again, lots of this is just applying rules for rotations, finding the rule based off the instructions, and then plotting the points. We mostly check these graphically just because they are hard to graph from scratch. So we use those rules, and you will continue using those rules on your homework. All right, that's it for 2.3. If you guys have any questions, send me an email. This key is posted, and you have 2 options for homework, so pick one of those. It's a Delta Math assignment, I believe, or a worksheet that is at the front of the classroom. See you later.